Hi, welcome back. How we know an substance is acid or base? Yes, I guess all of you will tell me. Look at the pH value. So, the pH value is range from 0 to 40. pH of 7 is neutral, less than 7 is acidic, and more than 7 is basic. But actually, how we calculate it? This is our objective in this video. Alright, in this slide, we are going to learn the definition for pH and pOH. But I believe that all of you still remember the definition for pH, and this one we already go through in experiment 6. pH equal to negative log H plus or negative log H3O plus. How about pOH? pOH is negative log OH negative. And then pKW is negative log KW, pKa is negative log Ka, while pKb is negative log Kb. So from these 5 examples here, we generally can say the symbol of P at here take the meaning of negative log of whatever follows in the formula. Besides to know how to differentiate acid and base, we also need to know how to differentiate between strong acid and weak acid, strong base and also weak base. So here I give you the table and then we look at the definition. For strong acid, dissociate completely. Then it will produce high concentration of H3O+. At where most of the time we will use the one-way arrow or irreversible arrow when we are writing the equation. So these are the 7 common strong acids that you have to remember. HCl, HNO3, H2SO4 is a very common acid that we used before. So means that now actually you just add on another 4 example of strong acid. HClO3, HClO4, HBr, and HI. While strong base is still get the definition at where it dissociate completely. But for the base, they will produce hydroxide ion. What are the examples of the strong base? All hydroxide. So means that if you can see from the chemical formula, if you can see there is OH negative or oxide with the formula O2 negative. For the for group 1 and group 2. Except beryllium. So means that all these are strong base. Now, let's continue with weak acid. So what is the definition for weak acid? Dissociate slightly, at where just only around 5%. Because only dissociate 5%, so the concentration of H plus or H3O plus is very low. So later we will continue when we want to write the chemical equation for weak acid, we will use reversible arrow. And most of the time you will see a Ka value will be given, which show that the acid is a weak acid. Another way around for weak base still is slightly dissociate, but then it will produce low concentration of OH negative. So what are the examples others than the strong base? That's why you need to remember example of strong acid and also example of strong base. So if you are given a substance, but then you know it is not a strong acid and then it is not a strong base as well. So how you know whether it is weak acid or weak base? So just now already mentioned, if weak acid, Ka value will be given, which means this A is represent acid. While if it is weak base, value of Kb will be given at where the B is referring base. Okay, now we are in the main idea of this video. We need to calculate the pH value for strong acid and strong base. Because of strong acid and strong base are dissociated completely, therefore there is no reactant are left in the solution. And we will going to use one-way arrow. Okay, following we're going to show you the step how to calculate the pH value for strong acid and strong base. So I also will make it in a table so that you can see what's the difference. So if we want to do the calculation for pH value, for strong acid we have 3 steps, but for strong base we are going to have 4 steps. Step 1, write dissociate equation and ICF table. So why this one we call ICF? For here, the F is stand for final. Because the arrow that we use is forward arrow only, means that it is not at equilibrium. That's why we didn't use the short form ICE. Second, we are going to calculate the concentration H plus at final. And then we use the formula pH equal to negative log H plus, means that the concentration at final here will replace into this formula. After you press the calculator, that will be the value of the pH. While for the strong base, first 3 steps actually are similar with the strong acid. But because of it is strong base, so what we calculate actually is pOH. So then we have to keep in mind that pH plus pOH always equal to 14. So we rearrange this formula. pH will be equal to 14 minus pOH. Let's look at the following calculation example. Now let's look at the example. First, calculate the pH of a 1 exponent negative 3 molar HCl solution. So we know that HCl is strong acid. So we recall the 3 steps. First one, or step 1, we're going to write the equation, which the type of arrow used is forward arrow. Step 2, we are going to write the ICF table as like this. So initially we have HCl solution. So the concentration given is 1 exponent negative 3. And then we have no H plus, and also we have no Cl negative. But then HCl is a strong acid, so it will dissociate completely. So means that we will minus the whole thing, 1 exponent negative 3. So it's like similar with our chapter 6, negative x. So this one is considered plus x. Since x is 1 exponent negative 3, so here will be plus 1 exponent negative 3 lah. Similar with the Cl negative. So for the final, still similar with what we do the calculation for equilibrium, we total up. Okay, so 1 minus 1 exponent negative 3, we will get 0. 0 plus 1 exponent negative 3, we will get 1 exponent negative 3, same as Cl negative. So then we go to the step 3. Step 3 is pH equal to negative log H plus. So you can use the calculator, press the negative log, and then we substitute the concentration of H plus at the final into the formula. Then you will get pH equal to 3. Now let's look at second example. This second example is given us the pH value, but then they ask us to do the calculation for the concentration of H3O plus. So same as well, we are going to use pH equal to negative log H3O plus. But this time we have 3.76 is given. So means that negative log H3O plus is equal to 3.76. So if I want to move this negative log to another side, what we are going to do actually is anti-log negative 3.76. So how to make anti-log in your calculator? So you press the shift and then follow by the log. After you press shift and follow by log, you will see this symbol. Then only you will put the negative 3.76. Once you press the calculator, this is the answer, 1.74 exponent negative 4 molar. Okay, let's look at one past year question. This question is asking us to look for pH value for an NaOH solution at where the mass is given and also the volume is given. Once mass given, we can find the number of mole. With the volume given, then we can look for the concentration. Then from the concentration here, because this is NaOH, so actually we can look for the pOH. Then only we can find the pH value. Okay, these are the extra exercise for you. So from here, before we start, just recall to check whether this one is strong acid or strong base or weak acid or weak base. HBr, strong acid. The H3O plus, so we know this one is an acid. Calculate the pH for H2SO4, acid. Barium hydroxide is base. Always remember we need to write down the ICF table. Okay, continue with question 5. KOH, strong base. Calcium hydroxide, strong base. HCl, strong acid. Try to answer these questions, and then if you have any problem at where you cannot get the answer as stated here, maybe my answer is wrong, then later we will discuss during lecture. So thank you for your time and see you in lecture.